Here we discuss about the gamma function. The gamma function is defined for all x positive, and it is defined as gamma of x is equal to integral 0 to infinity e raised to minus t power x minus 1 dt. This is the definition of gamma function at x. Okay. And this is called an improper integral. What do you mean by improper integral? Is an integral of the form a to b f of x dx, where either this a is minus infinity or this b is plus infinity or both. And also, if the function f of x takes a value closer to infinity for some c between a and b, then also it is called an improper integral. That is, either the limit becomes infinite or minus infinite, or the function takes the value infinity or minus infinity in between. It doesn't take the value, it goes to, that is the limit of f of x as x approaches c, the c is between a and b, it becomes infinity. Then we say that the integral is an improper integral. So that is why gamma function is an improper integral. See here, from 0 to infinity, here a is 0 and b becomes infinity. The function is okay, like it doesn't create any problem. It is e raised to minus t into t power x minus 1 dt, and it is because of the upper limit we call that integral as an improper integral. That's also called an Eulerian integral of the second kind. Now, what do you mean by saying integral 0 to infinity a function f of t dt? It is just the limit of, so you put integral say 0 to some t and take any function f of t dt, f of t integrate with respect to t, and you take the limit of this as t becomes very high, that is t goes to infinity. So this limit as t goes to infinity, integral 0 to t f of t dt, this is the meaning of writing integral 0 to infinity f of t dt. If this exists, if this quantity exists, then we say that this improper integral exists. Let us see an important property of gamma function. This property makes it as a generalization of factorial notation. Gamma function is actually a generalization of the factorial notation for positive integers. The property says gamma of x plus 1 is equal to x into gamma x for any positive value x. It's easy to see that. You see the definition of gamma function. Gamma of x plus 1 is equal to integral 0 to infinity e power minus t power x plus 1 minus 1 dt. That is e power minus t into t power x dt. Here instead of x I am taking x plus 1, so it is t power x plus 1 minus 1 dt. So that is why it is t power x dt. So if you apply integration by parts, it becomes t power x into integral of e power minus t evaluated from 0 to infinity minus integral 0 to infinity derivative of t power x, which is x into t power x minus 1, integral of e power minus t is e power minus t by minus 1 dt. Now if you put the upper limit infinity, what happens is, even though this t power x becomes infinity, it is dominated by e power minus t, which is becoming 0 as t tends to infinity. So the first upper limit becomes 0, and you put t equal to 0, e raised to minus 0 is 1, whereas t power x is 0. So the first term gives you only 0, plus this x will come out of the integration because the integration is with respect to t. X into integral 0 to t, integral 0 to infinity e power minus t power x minus 1 dt. Now this is nothing but gamma x. This is nothing but gamma x. So gamma of x plus 1 is equal to x into gamma of x. Also, if you take gamma of 1, it is nothing but integral 0 to infinity e power minus t into t power 1 minus 1, that is t power 0 dt. That is just the integral of e power minus t, which is e power minus t divided by minus 1 evaluated from 0 to infinity, and that gives you plus 1. Now you can easily see that gamma of x plus 1 is equal to x factorial if x is a positive integer. For example, like gamma of 1 is equal to 0 factorial, gamma of 2 is equal to 1 factorial, gamma of 3 is equal to 2 factorial, etc. It is easy to observe that. Say, suppose I am taking gamma of 7, I can write it as gamma of 6 plus 1, right? Now we have the property that gamma of x plus 1 is equal to x into gamma. So 6 into gamma of 6, that's equal to 6 into gamma 6 can be written as 5 into gamma 5. So into 5 into gamma 5. Now etc. So it goes like this: 6 into 5 into next 4 into gamma 4, 3 into gamma 3, 2 into gamma 2, 1 into gamma 1. Gamma 1 is 1. So this is nothing but 6 factorial. Like that, for any integer n, you can say that gamma of n plus 1 is equal to n factorial. So that's why we call gamma function as the extension of the factorial notation. For example, gamma of 3.5 or 3.5 can be written as 2.5 into gamma 2.5, right? Because of the earlier property. Now this is equal to 2.5 into, this 2.5 can be written as 1.5 into gamma 1.5. Now this is equal to 2.5 into 1.5 into gamma 1.5 can be written as half into gamma half, and we will see that gamma half is equal to root pi. So like this you can find the value of gamma function using the property gamma of x plus 1 is equal to x into gamma of x. So this is a very important property, and that will be used in many places. For example, when we study Bessel functions and all, we'll be using this property. Now from the observation that gamma of x plus 1 is equal to x into gamma of x, it is very clear that gamma of x, if it is known for the interval 1 to 2, you can easily find the gamma of x for any value between 2 and 3, that is 2 to 3. Why it is so? Because if you know the values of 1.1, 1.2, etc., then you can easily say what is the value of gamma 2.1, gamma 2.2, etc. Because gamma of 2.1 is nothing but 1.1 into gamma 1.1. So if we assume that gamma 1.1 is known to you, it is easy to write what is gamma 2.1. Similarly, gamma of 3.1 can be easily written if you know the value of gamma 2.1. So if you know the value of gamma function between 1 and 2, you can easily find the values of the gamma function between any value between 2 and 3. Okay. Similarly, we can go back also. Gamma of x is nothing but gamma of x plus 1 divided by x. So if you know the value between 1 and 2, you can easily find the values of gamma between 0 and 1. And you should note that gamma of 0 is undefined and gamma of negative values are also undefined. You cannot define the gamma of any negative number or 0. Also, for a greater than 0, you can see that integral 0 to infinity e power minus at t power minus 1 dt is equal to gamma x by a power x. It is just by putting at is equal to y. If you put at equal to y, you have a into dt equal to dy. You convert the entire problem into y, so that it becomes integral 0 to infinity e power minus y, t becomes y by a, right? So y by a power x minus 1 into dt will become dy by a. So a power x minus 1 into a will come out. So it will be gamma of x divided by a power x. We will also show that gamma of half is equal to root pi, and we will define a new function called a beta function, and we will see the relation between this gamma function and beta function.